Hello, we're here for Honors Physics Free Fall Questions and Problem. Taking a look at problem number 2 on it. It says, a stone is dropped from the top of a cliff. It is seen to hit the ground below after 3.5 seconds. How high is the cliff? So, draw my little sketch. That's always a nice way to start a problem. Right? So I have my cliff, right? A bunch of junk at the bottom. Stones that have been dropped previously, called a scree. All right, there we go. And so we're going to drop this stone off the edge. I know that as it falls, it's going to get faster and faster and faster, right? Okay, when it gets down to the bottom here, it's going to be moving honking fast, right? Okay, 3.5 seconds later, take time to speed up quite a bit. Okay, so there we go. Now, I like to list out my variables when I do motion problems. A, V naught, V, displacement, time, right? Okay, and see what I have to work with. Okay, now, the first thing is it's being dropped. As soon as I see dropped, I know two things. One is I anticipate that acceleration will be the acceleration because of gravity. Now, before I can assign a value, I need to decide which way I'm going to call positive. I am going to try to be consistent and call upward the positive direction of my problems. So that means my acceleration is downward. It is negative 9.8 meters per second squared near the surface of the Earth. My initial velocity, the second thing that being dropped tells me is that we're just letting go. So it starts from a speed of 0. So my initial speed is going to be 0. We're not moving up or down at all. We just kind of let go of the thing. Let's see here. We want to know it's seen to hit the ground below after 3.5 seconds. That's my time. It took 3.5 seconds to get there. Okay, to get down here. So our calculation is going, from here to here. Okay. And we want to know how high is the cliff. That's like asking, how far this is going to travel, what the displacement is going to be here. So if we get this displacement, we can find the height of the cliff from that. So put a question mark there. Now, as a side note, do we know the final speed? There is a tendency amongst people when they're first learning physics to say, oh, well, at the end, isn't it going to be stuck in the ground? Won't the speed be 0 at the end? But you got to remember, we're calculating just for the time when the acceleration is negative 9.8. After it hits the ground and the ground shoves back up to stop the rock, that's a different acceleration then. Okay, in fact, it'd be an upward acceleration. Trying to slow down this thing that has a negative velocity, got to have a positive acceleration. That's a different acceleration. We're not looking at that. We're just looking at it, this motion. Okay, and we're just modeling this one motion. We have a mathematical model to describe it. So we don't know what that final velocity is. It is definitely not 0. Okay, it starts from 0 and we're subtracting 9.8 meters per second every second. It's going to be some big negative value. Okay, so we're going to work with these variables. A, V naught, delta xt. It'd be swell if I had a formula that didn't have V, a formula for motion that just had these 4 variables. And guess what? We've got one. It looks like this. Delta x is V naught t plus 1/2 a t squared. So I'm going to use that formula. You know what we're trying to find? Delta x. Look, it's already isolated out for us. That was convenient. Here we go. Don't have to rearrange. What was the initial velocity of that? Oh, it was 0. So this whole term is just going to drop out because V naught was 0. All right, so that's nice. And then I've got 1/2 acceleration negative 9.8 times that time, 3.5 seconds squared. And we're all set here, ready to just go ahead, plug in the calculator to get my displacement. If I do that, 0.5 times negative 9.8 times 3.5 squared, my calculator spits out an answer, negative 60.025 meters. And you say, now, if you want to get really picky about it, okay, this negative, right? This is the displacement. The negative tells you direction. It says the rock went down. But when we talk about like how high is a cliff, people don't usually want you to say, oh, that cliff is negative 60 meters to get from the top to the bottom. Instead, they usually report the height of a cliff as a positive value. So my final answer, I'm probably just going to flip the sign on that and say it's 60 meters. Does that make sense? The displacement of the rock is a negative 60. but the height of the cliff is positive 60 meters. That's the way people will expect it. Now, as far as this, if I include all these digits, people will think that I know it that precisely, but we really had only like 3 sig figs here in the value they gave us. And this 9.8 technically is rounded off. It's usually like 9.79 something. Near the surface there. So, I'm just going to leave that as 60 or maybe even 60.0 meters. That would be nice. I don't think that I want to indicate that I know it that precisely. Again, don't sweat the sig figs too much. Okay, but that's the height of the cliff. All right, that's what I got for that one. And once again, note the procedure: a sketch, assigning values to variables, right? Showing the formula that you're using. We didn't have to rearrange this one. It was already arranged for the variable we wanted. Substituting in our values, really easy to follow along and see what got substituted in for what. Working vertically is really the way to go. All right.